Hello, everybody. All right, so we're going to continue with Chapter 6, Lesson 6.2, page 241, Generate Equivalent Fractions. And our essential question for this lesson is, how can you use multiplication to find equivalent fractions? Well, we introduced this idea in Lesson 6.1 as we were splitting the models in half and recognizing that, let's say, 3/5, if I multiply it by 2 over 2, then an equivalent fraction would be 6/10. So that's basically what we're doing today. So Sarah needs 3/4 cup of dish soap to make homemade bubble soap solution. Her measuring cup is divided into eighths. What fraction of the measuring cup should Sarah fill with dish soap? All right, so we know that she has 3/4 cup or she needs that, but she only has eighth cups. So what fraction of the measuring cup should she fill with dish soap? And so a basic question we need to ask ourselves is an eighth size part of a measuring cup bigger or smaller than a fourth size part? Well, keep in mind, if you were asked to compare these, the larger the denominator, the smaller the pieces. Okay, so 1/8 is less than 1/4. So we'd say it's a smaller part. Okay, so now, how can we solve this problem? Well, we're going to compare fourths and eighths. And so we're going to shade the model to show 1/4. So we're going to shade one part to show 1/4. Now to shade 1/4 using eighth size parts. Well, it's telling us that there's two parts in a fourth. Okay, and that makes sense with the drawing, right? They show the same amount of shaded space. Okay, so this one has one piece, so its piece is larger, and these are smaller. Okay, but it covers the same amount. All right, so how many eighth size parts do we need to make 1/4 size part? We need 2. All right, so every 2/8 equals 1/4. Now we're going to shade 3/4. So we have 3/4. And now we're going to model 3/4 using eighth size pieces. And remember, for every fourth, it takes 2 eighth size parts. So 2/8 equals 1/4. 4/8 equals 2/4. 6/8 equals 3/4. All right, so you need 6 eighth size parts to make 3/4 size parts. So she needs to fill 6/8 of the measuring cup with dish soap. Explain why 6/8 parts is the same amount as 3/4 size parts. Okay, so basically there are 2 eighth size parts in each fourth size part. So we needed 3 times 2. Okay, because we have 3/4 and we need 2 eighth size parts for every 1/4 part. So it would look like this. 3/4 times 2 over 2 would give us 6/8. All right, let's go to page 242. And on 242, the example says write 4 fractions that are equivalent to 1/2. Okay, so we have 1/2 is equal to 2/4, right? So the amount of shaded, no matter what, is still half of the circle. Okay, this one takes 2 pieces to equal half of the circle. This one only takes 1 piece to equal half of the circle. So 1/2 equals 2/4, which is the same as saying 1/2 times 2 over 2 equals 2/4. So if you multiply the circle with 2 parts by 2, it turns it into 4 parts. If we multiply the shaded part by 2, we now have 2 parts that are shaded. Okay, so that's why we're multiplying by 2 over 2. And now, why does that work? Because we're not changing the value of 1/2. If we multiply by 2 over 2, 2 over 2 is equal to 1. And any number times 1 is that number. So when we multiply it by 2 over 2, we're multiplying by 1, which keeps it as 1/2. So 2/4 is just another way of saying 1/2. All right, so now let's look at this one. It starts as 1/2, and then we have 6 pieces. Well, how did we go from 2 parts to 6 parts? We multiplied by 3. But I have to multiply by a value of 1, so the numerator also has to be multiplied by 3. So how many parts do we have shaded? 3. 3 times 1, 3/6. Okay, and the next one. So we still have our 1/2, but this time I see that we have 8 pieces. So what did they multiply by to get 4/8? 1 times 4 over 4. So 1/2 equals 4/8. And again, that does make sense because what's half of 8? 4. Okay, and the last one, we have 1/2, and it turns into tenths. So what would I have to multiply halves by to get tenths? I would have to multiply by 5. So there's 5 times as many tenths as there are halves. All right, so 5 over 5 times 1/2 would give me 5/10. So 1/2 is the same as 2/4, 3/6, 4/8, 5/10. And you could probably notice a pattern, right? Then it would be 6/12, 7/14, 8/16, and so on. All right, so now look at the model that shows 1/2 equals 3/6. How does the number of parts in the whole affect the number of parts that are shaded? And explain. So the whole for 3/6 is divided into 3 times as many parts as the whole for 1/2, right? We went from 2 pieces to a total of 6 pieces. So that's 3 times as many. Therefore, the model for 3/6 has 3 times as many parts shaded. Okay, so the whole for 3/6 is divided into 3 times as many pieces, or equal parts is what we should say, as many equal parts as the whole for 1/2. So the model 3/6 has 3 times as many parts shaded. 3 times as 1/2. Explain how you can use multiplication to write a fraction that is equivalent to 3/5. All right. In 3/5, the whole was divided into 5 equal parts. Think of the whole as divided into 10 equal parts. Since 10 is 2 times as many parts as 5, you need to find 2 times as many shaded parts as 3/5. So 3/5 times 2 halves equals 6/10. So in 3/5, the whole is divided into 5 equal parts. So we can think of the whole as divided into 10 equal parts. What did we do? We took the 5 equal parts and divided them into 10 equal parts by multiplying by 2. So since 10 is 2 times as many parts as 5, you need to find 2 times as many shaded parts as 3/5. So 3 times 3/5 times 2 halves equals 6/10. Are 2/3 and 6/8 equivalent? The answer to that one is no, because 2/3 times 3/3 equals 6/9, not 6/8. So you cannot multiply that fraction by a value of 1 and get 6/8. That's kind of what it would look like in an explanation in writing. No, okay, they are not equal. For instance, if I try to multiply by 3/3, because 2 parts shaded times 3 parts shaded would be 6. So that would be 3 times as many. But if the shaded parts are 3 times as many, the total parts have to be 3 times as many. So 3 times 3 is 9, not 8. Okay. So you cannot multiply the numerator and denominator of 2/3 by the same factor to get 6/8. All right, let's go to 243. All right, on 243, we're going to complete the table below. Okay. And this model shows me 2/3. And it's being changed into 1, 2, 3, 4 sixths. So that's what they're telling us. 2/3 is the same as 4/6. These two sections here are the same as those 4. So what did they multiply by to get 4/6? they doubled the 3, right? So 2 over 2 would give us 4/6. Okay, in our next model, this first one is 3/5, and it's going to become 6/10. So what did they multiply the 3/5 to get tenths? 2. 5 times 2 is 10. So do the same thing to the numerator. Multiply it 2 times. So we have 6/10 shaded. In the last model, we have 1/3 shaded. On the right-hand side, we have 4/12 shaded. So 1/3 times what would give me 4/12? 4. So we're going to multiply the numerator and denominator by 4. So 1/3, an equivalent fraction, is 4/12. All right, number 2. Write 2 equivalent fractions. Now there are multiple different ways of getting equivalent fractions. As long as you multiply the original fraction by the same numerator and denominator, you can multiply by anything. I'm going to use small numbers. Okay, so I'm going to use 2/2, and the next one I'm going to use 3/3. Okay, so 4 times 2 is 8. 5 times 2 is 10. So I turned it from fifth size parts to 10 tenths size parts. The next one, if I multiply the fifths by 3 times as many, I would have 15 parts. The number of shaded parts would be 12. So 4/5 is the same as 8/10, which is the same as 8/15. And you start to notice a pattern in the numerator and denominator. 4, 8, 12. The next one would be 16. The denominator would be 5, 10, 15, 20. 16 20ths, 20 25ths, so on. 2/4. Again, I'm going to multiply it just by 2 simple factors, 2 and 3. You can multiply by 5 over 5, 6 over 6, 100 over 100. As long as the number that you multiply the original fraction by is equal to 1, meaning the numerator and denominator are the same number, you can multiply it. It'll be an equivalent fraction. All right, so 4 size parts, if I double it, I'd have 8 equal parts, and 2 times 2 is 4. Now, if I multiply the fourths by 3 times as many, I would go from 4 parts to 12 equal parts. And I'd have 2 parts shaded plus 3 more, 3 times as many would be 6/12. Okay, so 2/4 is equal to 4/8, which is equal to 6/12. Somebody may say, is 1/2 also equal? Yes. Okay, you can go smaller as well. Okay, as long as the value of the numerator and denominator comes out to 1/2, which these are. What's half of 12? 6. What's half of 8? 4. What's half of 4? 2. I could put 6 in the middle here, right? What's half of 6? 3. Okay, so on. All right. But as far as multiplying by 4, we wouldn't change it into 1/2. Okay, you can't really multiply 2/4 by the same whole number to get 1/2. You'd have to divide. Okay, and so that's a different lesson. Okay, that's what we would be doing if we were simplifying a fraction. All right, write 2 equivalent fractions. 3/6. So 3/6 times 2 over 2, so I'm going to double it. And I can also multiply it 3 times. 6 times 2 is 12. 6 times 3 is 18. Double the 3 parts that are shaded, I wind up with 6. So 6/12 and 9/18. Oh, you mean we're counting by 3/6? 3/6? 3/6 plus 3/6 is 6/12. 6/12 plus 3/12 is 9. I'm sorry. 3/6 plus 6/12 is 9/18. Okay. So we're doing multiples of that fraction, basically. 2 sets of 3/6 is 6/12. 3 sets of 3/6 is 9/18. All right, 3/10. 2 sets of 3/10 is 6/20. 3 sets of 3/10 is 9/30. So again, in a sense, we're skip counting by 3/10. I should rephrase that. We're counting by multiples in this case. Again, we're taking two. Actually, I take back that. Okay, I think I might be confusing you. Let me go back to here. Okay, so 3/6. If we were looking for a pattern, we notice that the 3 in 3/6 is increasing by 3 each time. The 6 is increasing by sixths each time. Okay, and that's why we're multiplying. We're multiplying by a value of 1. We are not using a multiple. Okay, so I want to clarify that. We are not using multiples here. We're using a value of 1. Okay, as a whole number. The fractions, if the numerator and denominator are 1, are the same. They equal 1. So we're not changing the value of the original fraction. All right, 2/5. Again, if we start with 2/2, we'd get 4/10. If we multiply 2/5 by 3/3, we'd get 6/15. So the pattern on 2/5 would be 2, 4, 6, so on. The denominator, 5, 10, 15. Okay. What would be the next one? If I didn't multiply by 4/4, I could go 2, 4, 6, 8, 20ths by just using a pattern of those numbers. All right, tell whether these are equivalent to each other. Okay, so you just choose one of the fractions. And since we're multiplying, I'm going to choose the smaller size parts. I'm sorry, the smaller denominator. It actually is a larger piece. And see if I can multiply by anything to get that number. So can I multiply 6 to get 18 equal parts? I can multiply by 3, right? But I can't multiply the numerator by something different than 3. So I also have to multiply the 5 parts by 3. 5 times 3 is 15. Well, 15/18 is not the same as 10/18. So no, that is not equivalent. 4/5 times something, does it equal 8/10? All right, let's look at the denominator. How can I go from 5 parts to 10 equal parts? By multiplying by 2. Okay, so I also have to multiply the numerator by 2. Is 4 times 2 8/10? Yes, it is. So this is equal. 1/5 times some fraction to get 4/10. Okay, so 1/5. I'd have to double the fifths. So I also have to double the numerator. 5 times 2 is 10, but 2 times 1 is not 4. So that is not equivalent. 1/4 times some fraction equals 2/8. Well, to go from 4 equal parts to 8 equal parts, I'd have to multiply by 2. So I'm going to multiply by 2 over 2. 4 times 2 is 8. 2 times 1 is 2. So yes, this is equal. All right? So let's go to 244. All right, Kim says the amount of flour in the recipe, it would help if you guys could see it, right? Kim says the amount of flour in the recipe can be expressed as a fraction. Is she correct? And explain. So the recipe we're using is over here, and it says faint. That's funny how your brain will combine 2 words into one. Face paint recipe. Okay, and we have 2/8 cups cornstarch, 1 tablespoon of flour, 9/12 cup of light corn syrup, a 1/4 cup of water, and a 1/2 teaspoon of food coloring. So she says that the amount of flour can be expressed as a fraction. Is she correct? Yes. So one, we've kind of been talking about that. We're finding equivalent fractions because we're multiplying by a value of 1, but we're not using the whole number 1. We're using the fractional value of 1. So when we say 2 over 2, that's 1. Okay. So if we write 1 is equal to 1 over 1, that's true. If I say 1 is the same as 2 over 2, that's true. 1 is 3 over 3, that's true, so on. Okay. So as long as the numerator and denominator are the same, I can express that as the value 1. All right, how could you use a 1/8 cup measuring cup to measure the light corn syrup? So the light corn syrup is 9/12. So we're going to have to do a little manipulating here because we know eighths. How can I get eighths? Well, that could be a fourth, right? And I could double the fourths to eighths. So how can I go from fourths or from twelfths to fourths? So this is what I'm asking you. What could I multiply some value, some fourths, times what would give me 9/12? Well, this fourth is 3 times bigger than 12ths. So what number times 3 would give me 9? 3. Okay, so 9/12 equals 3/4. I can multiply 3/4 by 2 over 2 to get 6/8. Okay, so if I had to get something that was 9/12, I would have to use 6/8 cups. Explain using words how you know a fraction is equivalent to another fraction. Well, if you multiply the numerator and denominator of the first fraction by the same number and the products are the numerator and denominator of the second fraction, then the fractions are equivalent. So, like in this case here, 3/4 is equal to 9/12 because I multiplied the numerator and denominator of the first fraction and it gave me the numerator and denominator of the second fraction. multiply the numerator and denominator by the same number and the products are the numerator and denominator of the second fraction, the fractions are equivalent. All right. So what we've been doing is finding out if fractions are equivalent by multiplying the numerator and denominator of the first fraction by the same number. And when I multiply them, the products, the answer to that multiplication problem, give me the numerator and denominator of the second fraction. Therefore, the fractions are equivalent. All right, number 14. Kyle drank 2/3 cup of apple juice. Fill in each box with a number from the list to generate equivalent fractions for 2/3. Not all the numbers will be used. All right, so 2/3, and we want to use numbers from the list to generate equivalent fractions. All right, so 2/3. What did they multiply 2/3 by to get 6 equal parts? They multiply by 2, correct? So 2 times 2 is 4. So we're going to use 4/6. All right, what did they multiply 2 by, 2/3 by, to get 12 something? 2 times 6 is 12. So multiply the denominator also by 6, and that would give me 18. So 12/18. Okay, now, which ones of the remaining fractions would be equivalent? Well, it looks like it's got to be a number. The numerators are increasing, and the denominators are increasing. So what could I multiply by? What can I multiply 2/3 by to get one of the other fractions? So let's look at the thirds. Which one of these is a multiple of 3? 6 is. Well, we've already got sixths, so I don't think it's that. 3 is also a factor of 12. It could be 12ths, but then it wouldn't be increasing. 15, and again, it wouldn't be increasing. So maybe it's not going to be something that's increasing. So if we multiplied, we're going to have to try some different things, right? If it's 6, if they change it from 2/3 into 6 parts, I would get 4/6. Well, I already used 4/6. So I don't think it's going to be the 6th. Okay, so let's try, what could I multiply by to get 12ths? Well, I could multiply both of them by 4, right? 3 times 4 is 12. So 4 times as many shaded parts as 2 is 8. 8/12. There is an 8/12. So that will work. It's equivalent. Let's try 15. Well, what I have to multiply thirds by to get 15 parts? I'd have to multiply by 5. 3 times 5 is 15. 2 times 5 is 10. So no, 15 won't work either. And 16, that would make us have a fraction that's greater than 1, and it wouldn't be equivalent to 2/3. So those are the answers. So 2/3 is equal to 4/6, which is equal to 12/18, which is equal to 8/12. So that's it for lesson 6.2. In our next lesson, lesson 6.3, we're going to talk about dividing fractions by the same numerator and denominator to simplify a number. Okay? So until then, may the numbers always be in your favor.